Today we're going to start talking about radical expressions. So they're different. Radical expressions. So we're done with rational. Rational expressions are fractions. Fractions with polynomials. Today we're going to be talking about radical expressions. And we're going to learn what they are. We're also going to learn how to simplify them, add, subtract, multiply, divide, and solve equations involved in them. Basically, everything we did with the rational expressions will also be done with radical. And these are totally different. We're not going to do the graphs right now. We did the graphs the other day. And they're totally different. So do not confuse radical and rational. Again, rational is fractions with polynomials. For example, p over q, px over qx, two polynomials. But radicals are numbers with a radical symbol in them. I'm sure you have seen them before, or at least some simplified form of them. So radicals is an expression with this symbol in it. So what we call the radical symbol. And there's always a number inside here. Let's say maybe some base to some power. And there is a little number here, most of the time invisible. That's the index, okay? Index n. So base, power, this is a radical sign, and this is the index. Each radical must have an index. Just like numbers, all numbers have powers, power 1, 2, or -2, whatever. These radicals must have some index here. It changes. Could be 2, could be 3 or 4. We'll talk about it in detail later. So this is the base. Of course, that's the power. This number here is also called the radicand. So this number here is called radicand. Basically, whatever is under the radical symbol is called the radicand. And of course, this is the radical symbol. Okay, so that's basically what a radical expression is. It's just something that's written like this with all these components. Simple example that you might be familiar with is something like this. We usually read this as, for example, this. So this, we're used to calling this the square root of 9, which we know is 3. We also can call it the radical of 9. So the radical of 9 is 3. Square root is a special type of radical, square root. But all of these, we can call them radicals. So radical 9 is 3. And so this is a radicand, okay? The number that's under the radical. This is a radical symbol. And we have a little symbol here, or a little number that's invisible. When this is a square root, the radical here, or the index, is 2. Okay, so with the radicals, if you don't see an index, by default, that's 2. Not 1, but 2, okay? And if it's different than 2, it has to be written here. For example, 3, 4, 5, 6, could be anything here. You're also familiar with, for example, this. Okay, this is, you say the square root of 25. Or you can also say radical of 25. Radical, or even better if you say radical index 2. Okay, you can say radical index. Okay, index 2 of 25 is, of course, 5. Okay, so you can say radical index 2 of 25 is 5. So that's how you read. This is a formal way to read the radical. And some radicals have special names, for example, the square root. If this is 2, it's called the square root. If this is 3, we call it the cube, cubic root, and so on. I'm going to talk about those cases in detail. But first, let's understand what this is before we talk about radicals with different indexes or indices. So basically, when we say 3 to the second, which means 3 times 3, it gives us 9. This is just an exponential expression, okay? Exponential expression. When we expand it, we get to this exponential, not radical, but exponential expression. Okay, simply because we have an exponent and a power. But sometimes we need to go back to the original number or the root of the number that was squared. Let's say we didn't have this. So we want to go back to 9, the base. So we take the radical of this. So we say radical 9 is 3. In other words, we say what number was raised to the second power to get 9. So we go to the original or the root of this. That's why we call it the square root. With the case of 2, we call it the square root. So the square root of 9 is 3. In other words, square root of 9 is 3. In other words, what number multiplies by itself twice to get 9? That number is 3. What number multiplies by itself twice to get 9? That number is 3. That's what we know so far. That's what we're familiar with. Same thing here. When you say radical index 2 of 25 is 5, it's like saying what number multiplies by itself this many times to get this, or to get this. What number multiplies by itself this many times to get this? That number, of course, is 5. So when you say 5 to the second is 25, this is exponent form. But to go back, we do the radical. Okay, so we take the radical here of 25 to get to 5. Okay, so let's write that in a sentence. It's very important to understand this sentence. That's what we're going to apply to all the other radicals with different indexes. So we say, what number multiplies okay, this many times, twice, to get, or to get, that's right, 9. That's another way to read this expression here. So what number multiplies by itself this many times, the index, whatever it might be, multiplies by itself twice this time to get 9, that number is 3. If we use the same concept, and we take this number here, again, that's another radical expression. So the radicand is 8, the radical, the index. We want to find what this is equal to. So always try to read it in this form. If you read it in this way, it makes sense and you can easily find a number. So in this case, we say, what number multiplies by itself 3 times to get 8? 2. That's right. 2. Exactly. The number is 2. So the number is 2. And you can check a number that multiplies by itself 3 times to get 8 is 2. Let's see if we times this by itself 3 times. 2 times 2 times 2 is in fact 8. Why 3 again? Because of the index. That applies to any index. Just think of it this way to find the number you're looking for. Let's do another one here. So 16, for example, and radical 4. Again, this is not a square root. It's not 4 here. It depends on the index. So if you don't see the index, that's when it's 2. That's when it's the square root. If you don't see it. If you do see it, then, I mean, if it's not 2, then we have to write it down. So this is the only time when it's a square root. Specifically, square root means times, number times itself to get this. Other than that, it's a different index. This one here.
The answer is 2? Also 2?
That's right. So we say what number multiplies by itself 4 times to get 16.
That's 16.
4 times. So you can try different numbers on the side. That number is 2.
Mm-hmm.
And to check it, simply take this, raise it to this power, and it should be equal to this. So this is a radical form. We can easily transform this into exponential form. What you do is take the number here, raise it to this index. That will be equal to this number here, 16. So if you expand this, you must get this. If you don't get the same value on both sides, that means your answer is incorrect. So radicals are just opposites of exponents. Okay, so this here said exponents. So here we raise a number to a power to get a number. Here we take the radical or the root of that number to go back to the base. We take the root of this number of this index. Okay, so the index here is 2. We say the root index 2 of 25 is 5. So that's basically the whole concept of radicals. Sometimes we raise a number to a power to get a number, and other times, for whatever reason, you want to go back to that number. So you use the root, the original number that you used. So, for example, here again, when you raise 2 to 4, you get 16. But sometimes you want to go backwards. So you're going to take the root of this. You're going to take the root of this with index 4 to get the 2. So you say radical index 4 of 16 is 2. So that's basically how radicals work. Radicals are just opposite of exponents. One, you may say, increases the number or multiplies the number. The other one basically just bring you back to that specific number, that specific base that you took and you amplified with a power. And it could be of any like I said, the index expected to be any number here. But let's take another example. If you take, always pay, the first thing you want to check is this, that's basically the index. So that tells you what you're looking for. It's not always square root, okay? Square root, forget about it. It's the only thing that we're familiar with so far. 9 is 3, square root of 25 is 5, but only if you have 2 here. If you have a different number, again, think about, read your radical in this form here. You say again, what number multiplies by itself this many times to get this number? That number is 3. What about this one here? This is what we call, so
9.
3, teacher.
I think it's 9.
So
Yeah, it's 3.
3.
That's
9,
right.
3 and 3, 9
That's
multiplied by 3, 27.
That's right, it should be 3. Because again, what number multiplies by itself 3 times to get 27? That number is 3. If you say 9, okay, take 9, raise it to 3. Do you get 27? No. If you take 9, you raise it to 3, it's not going to be equal to 27. So to check again, you have to take your answer, raise it to this, you should get this number. So you change the radical form into exponential form. This to this power is in fact 27. Because 3 times 3 is 9, 9 times 3 is 27. Okay, so again, we can switch back and forth between any radicals. We can turn any radical expression into exponential form and vice versa. So let's go back to this original form or notation. So there's always some power here, or base, there's power, there's index. And we can turn this, say this is equal to some number A, for instance. This is equal to number A. Let's switch this to exponential form, just like we did here and here. If you want to turn this into exponential form, what number to what power equals what? If you want to change this. So this to this power equals this. Let's do the same thing here. What would that be?
A to the power n
That's right. Equals?
equals b, what, b, p?
That's right. So you take A to the power this, and that will be equal to that. So let's write it down. A to the power n equals b to the power p. This could be just, for example, 9, or could be 9 to the second. There's always a number to a power. For example, here, the number here is 9 and the power is 1. Okay, it's possible to have 2 here, or 3 or 4 as a power, depends. So there's always a power, whether it's invisible or not. We assume there is 1 there. So that's one basic rule, the first basic rule of radicals. Just remember that any radical, you can go from here to here and here as needed, back and forth. And to simplify a radical, just read it in this form. Again, you can easily find the number you're looking for. Sometimes it's not a perfect root, just like with numbers, for example, when you say, we can do radical, let's say 4. Square root of 4 is 2, but the square root of 3, it does exist, it's a decimal, so it's not a perfect root, it's a decimal. I believe it's 1 point, I believe maybe 65 or something. So radicals are not always perfect, sometimes are easy to see. For example, radical, we all know radical 9 is 3, square root of 9 is 3, but we don't know exactly the square root of 8. It is a decimal number, but it's not a whole number, or a whole number like this one. So 8, I believe, is probably 2 point something. If I had to guess, it's not 3. 3 times 3 would be 9. So it's close to 3, maybe 2 point, let's say 3 or something. If you times 2 point, no, maybe a little more than that, probably 2.5 or something like that, or 2.6, approximately. So not all the radicals have perfect roots. When they're easy like this, we can do them right away. Other times we may need a calculator. For example, for radical 8, to get the exact value, you need a calculator. Same thing here. I believe it's something like this. It's not that important at this point. When we need to, we can use a calculator to find these values. Could be, again, any radical. Let's do one more example here. Actually, let's go to the next section. Next section, we're going to have more examples. So that's your introduction to radicals, a lot of definition. We have a lot more to talk about when it comes to radicals. We're going to explain, we're going to go over all those rules. So now we have a lot of situation here. Sometimes you may have negative. You may have a negative number here under the radical. Okay, let's see what happens when we have a negative radicand. Again, the radicand is the number that's inside or under the radical symbol. Could be an expression, could be a number, could be anything. Whatever that is, we call it radicand. So it is possible to sometimes have a negative here, but only in certain cases. You could have, let's say, maybe 3 and 8, depending on the index. But if you have something like this, so let's try to look at these two examples here, try to figure them out. And again, the easiest way to do this, always read it in this form. So here we say again, what number multiplies by itself 3 times to get -8? Do we know that number? Does it exist or does it not?
Yes, we know that it exists.
What is it?
-2.
-2, teacher.
Okay, so -2, let's check. So if you take -2 and times it by itself 3 times, let's see if we get exactly -8. So this is 4 times -2. That's in fact -8. That's good. That checks. So you put this here. So the number is -2. You can always check it out by taking this, raising this power, and see if it works or not. Now let's see if we can find this. What number multiplies by itself twice to get -9? Or is that even possible?
3.
3.
If you take a number and you multiply it by itself, do you get -9? You say
-3.
-3.
okay. Let's take -3 and multiply it by itself. Do you get -9?
No.
You do not. So it's going to be positive. So there is no number that you multiply by itself to get a negative number. Does that make sense? When you multiply two numbers of the same sign, the outcome will always be positive, right? So this number is undefined, at least in the group of real numbers. That's undefined. Okay, so no number multiplies by itself into a positive. The result will be definitely negative. I mean, multiplies into negative. The result will always be positive. Whether you take two negatives here or two positives, will not be this, exactly this. It's actually positive here. So when you times a number by itself, whether the number is negative or positive, it's going to be positive. Same thing whether if the index here is 4. Okay, the index here is 4. Is there a number that you multiply by itself 4 times to get a negative? If the index here is 4 instead of 2, can you get a positive or can you get a negative by multiplying a number by itself 4 times?
Yes.
Can you get a negative, for example, here? Can you get a negative number by multiplying a number by itself 4 times? Everybody?
No.
Teacher.
No, because this is an even index. Every time you multiply it, it will always be positive. As long as this index is even, each two signs will turn into a positive, each two into a positive. The result will never be negative. Okay, so here's the rule. So if the index is even, that means 2, 4, 6, or 8, you cannot have a negative here. You cannot, it is not possible. When you multiply a number by itself an even number of times, you will never end up with a negative. So this is also undefined. Okay, so whenever you see a negative under the radical, look at the index. If the index is even, again, even meaning 2, 4, 6, and 8. If the index is even, this cannot be negative. Okay, because whenever you multiply a number by itself an even number of times, it's always going to end up positive. It will never be negative. But if the index is odd, so odd numbers are these. Let's say 3, 5, 7, and 9. Yes, it is okay to have a negative here as long as this one is odd, not even. Okay, so that's important to see with the radicals. If you see something like this, you can immediately say that number is undefined. You don't have to find it. You don't have to try to find something that's undefined. But with odd index or indices like this, it is possible to have this. And you can easily prove it yourself. Just take whatever number you think is the answer and raise it to this power and see if you can get this exactly. If you think this exists, like you did earlier here, you say, oh, I think it's 3. If you multiply 3 by 3, do you get exactly this? No. You might think it's -3. If you multiply -3 by itself, do you get a -9? No, you get positive. So that's undefined. Does that make sense, everybody?
Yes.
Hey, everybody else? Any questions? It's very important that you understand these concepts here. We're gonna write these rules down. I'm gonna do a couple of practice problems on them. Okay, let's write these 2 rules that we just did here. Write them in sentences first. So if, let's take a radical expression. Index here, and maybe maybe x. So if n is even, x cannot be what? X can't be just like here, x can't be what sign? If this is even, the number here can't be
Negative.
exactly, can't be negative. That's the first one. And of course, the opposite of it, the opposite of this rule, if n is odd like this, then x, the radicand, can be negative. Okay, so even can be negative, but odd can be negative. And again, you can easily check for yourself whatever you think the answer is. Try to raise it to the index and see if you get exactly this. So of course here we are applying the rules of multiplication, the signs of multiplication. Keep that in mind. So let's see if we can do a few examples of that. So these are the 2 main ones for now, so keep these in mind. So whenever you see radicals, you first want to check if it's defined or undefined. So this here is undefined. We can't have a negative here as long as this one is even, but this is fine. This here is fine, is defined. As you can see, its value exists. It's -8. Let me give you a few examples here. What is the square root? Or before I write this, let's say just let me put 36 here. What is this expression equal to? What is the value of it?
Six to the power 2. I mean,
And just the answer here. What is this equal to? the value is. It's basically square root of 6 or radical index. What is the index of this radical if you don't see it?
2.
2.
Right? 2. So by default, if you don't see it, it's 2. It means square root. What is the square root of 36?
6.
6.
That's right, 6. And you can easily check. You say 6 to the second equals 36. 6 to the second equals 36. What if I said 36 or negative 36? What do you think of this one?
Undefined? No?
That's right, undefined. When you have a negative here, check here. If this one is 2, 4, 6, and so on, if it's even, then you immediately say undefined. You don't have to do anything else. Don't try to find a number, it's undefined. What if you see this? I don't need the answer. I just need to know whether it's defined or not. Is this defined or not?
No.
Okay, why not?
Because it's negative.
That's right, because there's a negative here, and this is odd, and this is even, so you say undefined. What if instead of 4 here, I had 3 on the same number? I had a cube here, 3 or 5 or whatever it is. Is this value defined or not?
No.
Why not?
Like, it's the same, right? Just different
Yes,
number.
it is.
What makes it defined?
Because it's a
Oh, it's 5.
only
Okay.
on an odd number.
It's
What-
odd. Oh, okay. Got it.
What is odd? What's odd number?
3, 5,
5.
7.
5.
Okay, what do we call 5? What's the name of it?
The
Yeah.
roots?
No.
That's good. So 5 is index. Okay, the number that's here is called the index. So when you see a negative here, check for here. If it's odd, meaning 3, 5, 7, 5, then this is fine. This is defined. Okay, so sometimes again, before you even try to do anything with radicals, don't waste time. For example, here finding something that doesn't exist. So know your rules. You can immediately save time instead of trying to chase something that does not exist. Let's do another one here. So before you look for the answer, first check whether that answer exists or not, defined or not. Is this defined? Everybody in the class, I'm talking to you, not just to a couple of people.
Yes. Yes, it is.
Okay. What makes it defined?
It's an odd number.
Because the index is odd number. That's right.
It's an index, yeah.
Mhm. What numbers multiplies by itself 3 times to get negative 27?
2.
Not 2.
Oh, I mean,
3. 3. Not
3. Yeah.
Not 3.
Minus.
Right? Negative 3. Because we want to get negative 27. So if you take this number negative 3 times it by itself 3 times, you will get negative 27. We need to get exactly this with the sign. So this number is defined and is equal to negative 27. So that's important when it comes to the radicals. When you see a negative inside, be careful. Make sure that's that number. Nobody's going to tell you to check. You have to know that you need to check. Before you, again, you try to find the answer. It might not be a defined answer. You may waste time trying to find it. What about this one here? Let's say negative. let's say 4 here. Again, is this defined or not? Everybody, is this a defined radical or not? That's the first thing you do using these rules.
No,
Find the value. Why do you think it's undefined?
it's undefined because
There is even index,
the
right?
index is even.
And what else? Index is even and what?
A
And
negative
the exponent
sign.
is, yeah, a negative sign.
But is this a negative number?
Basically, when you open the parenthesis is gonna be positive, yeah?
Okay, so this is not a negative number. Even though you
Yeah,
put
it's gonna
negative,
be 9.
negative
Oh.
to the second is 9. So this is not a
Mhm.
number. Only undefined if this number is negative and this is even. This is not a negative number. This is actually positive 9, not negative 9. So if it's not negative, you don't have to say defined or not. I mean, you don't have to check for the index. Only check the index if the number is negative. If the number here is not negative, for example here, even though you see a negative, it's actually a positive because it's negative, not a 3 to the second. So no need to check the index to see whether it's defined or not. By default, that's defined. There's no problem if the number is positive. Okay, so keep that in mind. Just because you see a negative here doesn't mean the number is negative. So this is actually, okay, this is defined. And this exists. This usually, you would need a calculator to find this value. What number multiplies by itself? 4 times to get 9. That number is probably 1 point something. So this would require a calculator. Okay, so keep these in mind. And basically, radicals are just the opposite of exponents. Okay, so radicals are the opposite of exponents. We can turn any radical into an exponential form, and then we can evaluate it or simplify it. Okay, now we'll see how to simplify some more radicals. Let's go to another unit. Any questions, everybody, at this point, before we move on to the next step? Everyone?
No questions.
No question.
Others? Okay, so now we're going to see some more examples of simplifying radicals. Let's see. So this will be number 3. So simplifying radicals. Okay, so as we saw earlier, for example, when you have square root of 16, we know that's 4. But with square root of 8, again, the index it is 2. If I don't write it, that means it's 2. Well, here the number is a decimal, is like I said, 2 point something. We can either use a calculator if we want the exact value, or sometimes we don't want to change this into a decimal. We just want to simplify this into another radical that's simpler than this. So to do so, basically you just take this number and you break it down into a product, into a multiplication of 2 numbers. One of them might have a perfect square. For example, here the index is 2. We can't find the square root of 8, or at least we need a calculator to find it. But what we can do is can turn 8 into two numbers. 4, for example, times 2. Then we can split this into two radicals. One of them will be able to simplify. For example, here we're going to have radical 4 times radical 2. And what's radical 4, or the square root of 4? Everybody, what is the radical or the square root of 4? Again, the index is by default 2. That means it's square root. What is the square root of 4, or the radical index 2 of 4?
2.
That's right. This we know. So now we can turn this into just 2. But this one here, it doesn't have a perfect root. A number that multiplies by itself twice to get 2, twice here to get 2. That number is a decimal. So this can't be simplified, can't be reduced, or can be broken down into two numbers. We'll leave it like that. Okay, so this turns into 4, and this 2 stays inside the radical. So when we simplify radicals, we basically try to get this number here as small as possible. We try to break it into numbers that have perfect radicals. So radical 8 is the same as this. This is not the index. The index is invisible here. It's hidden. This is 2 times. This 2 came from here. Okay? This whole thing turned into this 2 here. Times this radical 2. And the index is still invisible there. So this 2 times, and there's the radical. Let's see another example, maybe say 24. So the square root of 24, 24. We do know the square root of 25. What's the square root of 25 again?
5.
5. Index is 2, but with 24, might be close, but it's not exactly 5. It's very close to 5, 4 point something. But we want to simplify it into another radical, not a decimal. Unless we're interested in a decimal, we can use a calculator. So since 24 doesn't have a perfect root, so what do you do to simplify this? What do you do to simplify the 24?
12.
That's right, we can break this down.
12 multiplied by 2.
That's right, we're going to try to break this down into a product of two numbers, and hopefully one of those numbers will have a perfect root, just like here 4 and 2. 4 has a perfect root. 24, we can turn it into different numbers, either 8 times 3.
Wouldn't 4 and 6 be the best one?
Probably, that's right, 6 times 4, and then we have 12 and
2.
12 and
2.
all these, that's right, all these multiply to 24, but which one of them has a perfect radical, or the highest radical?
12.
12 doesn't have a perfect radical.
And 4.
So 4 has a perfect square root. This is not doesn't have a perfect square root. It doesn't have, the only one that has a perfect square is this one. If there was another one with a perfect square, we take a perfect root, we take the higher one. But 12 here doesn't have a perfect radical itself. So basically we're going to take that instead of the other ones. And we're going to turn this into radical 6 times radical 4. And this will be radical 6 times radical 4, which is 2. We can move this 2 to the front now. We can say 2 radical 6. So we turn this one into that one. So you get something inside that's smaller. So you used to be 24, now we have only 6. you can't do anything else. Even though you can break down the 6 into 2 and 3, it's not going to help. 2 and 3, none of them has a perfect root. So that's the idea of simplifying radicals. We basically try to get the number under the radical as small as possible. So it's up to you to figure out which combination is the best. Let's look at another example here. Let's say you want to simplify. As always, we would prefer to have perfect ones, but it's not always the case. So for example, what is the radical index to a 49?
7, teacher.
That's right, 7. This is square root. But unfortunately, if it's 50, so that's not as convenient. Again, by default, if you don't see an index, that's 2. The square root of 50, it's a little over 7 point something. But we want to turn this into a simplified radical. So what do you do again to simplify this into some smaller radical?
25 and 2.
That's right. We turn the 50 into a product, but not any product. It has to be a specific one. So 50, we can get it by times in 10.
And 5, teacher.
10 and 5, or?
So it's
25 and 2.
Exactly. Which one would you take to simplify?
25.
25.
Exactly. This is not going to help because this doesn't have a perfect root. This doesn't have a perfect root, so that's not going to work. This is the best option to choose. So we're going to say 25, okay, times radical 2. And of course, radical 25 is, or the square root of 25,
5.
is 5. And this stays. We can do it with a calculator, but we prefer for now to keep everything in radical form. And that's basically it. So that's how you turn radicals. Try to get this number as small as possible until you can't break it down anymore. So here we can't do much with 2. 2 is 2 times 1. So if you break it into 2 and 1, it's not going to help much. So we'll leave it like that. So this whole thing we were doing, we were talking, doing these examples with index 2. But again, it's not always 2. It could be any index. Let's try to do an example with another index, maybe 3. And let's say 16. So do you, is there a number that multiplies by itself 3 times to get 16? A whole number that is? Can you find one?
I guess no.
That's right. So this is not a square root, it's 3.
2 and 8, teacher.
Say again?
2 and 8.
2 and 8. Okay, that's
Yeah, it's gonna be 8.
So since we can't find this number, it does exist, but it's a decimal. So
Can't we just use 4 by 4?
if you use 4 by
No, it has to
Oh
be
no,
3
it's
times,
3.
yeah?
Yeah, it's not
Yeah.
a square. It's 3. Yeah.
exactly.
Correct.
If this was 2, then you would just say 4 here. But so instead, we're going to use turn the 16. So again, we can turn 16 in different things. So we can say 4 and 4. We can say 8 and 2. But again, think about the index. So only one that will work for this example is the 8, because we know the root of 8 index 3 will be, we're going to see at the next step. So I'm going to turn this into 8. And 2 here and 2. You always have to write the index if it's different than 2. If it's 2, sometimes it doesn't have, you don't have to write it. Just like, for example, x. When you have x, you don't have to write power x, power 1. You can just write x. But if it's any other power, 2 or 3 or 4, you have to write it. Something with the radical. If it's different than 2, then we have to explicitly write that index. Okay, let's simplify this one here. What number multiplied by itself 3 times to get 8?
2.
2, that's right. And here the numbers are multiplied by itself 3 times to get 2. We usually would need a calculator to do that, so but we don't have to. You can leave it as a radical. Don't forget the index. If you don't put 3 here, then it basically means 2, means index 2, but it's not index 2, it's index 3. So the index has to be the same. And that's basically the simplest form of this one. So regardless of the numbers you have here, the same method, just break it down. You may have, if the number is bigger, you may have to break it down more. So you keep breaking it down until you can't simplify anymore. Let's see again, maybe some other example.
Professor,
Mhm.
I have a question. Again, why it's 8?
I'm sorry, tell again?
Why it's 8?
8
Like
here?
yeah,
Because
I
we,
didn't get it because it's the index is 3. So
Mhm.
basically we do the same like the index is 2. I mean, I
Yeah.
don't know. What's the difference?
The difference is the index. So
Yes.
you break this number down into some numbers that you know the root of index 3 of. We couldn't use 4 on 4 because we don't know for example, if we turn 4 on 4, we don't know the radical of 4 index 3 as a whole number. It is a decimal, but we used 8 because we know that 8 has a perfect radical. Number that multiplies by itself 3 times to get 8 is 2.
Mm-hmm.
So these are the only 2 options. So we use the one that's convenient because again of this, because of 3. If it was 2, then we wouldn't have to do anything. If it was 2, we would just say 4. Square root of 16 is 4. But the index here is different. So we have, it's up to you to figure out 2 numbers, and one of which will have perfect radical. For example, here with index 2, we have 2 options. We use this one because 25 has a square root, which is 5. This one stays the same. Okay, so it all depends on the index. Let's do another example here. Let's say 32. What is the index of this radical? What's the index here? Everyone? What is the index of this radical here?
Yeah, 4 by 8.
I'm asking what's the index? What is the index? Not
The index is 2.
That's right. The index is this letter number here that's invisible. If it's invisible, then it's 2. Otherwise, you write it down. So the index is 2. Okay, that means radical 2. So always you want to identify the index first because the index is very important, especially when dealing with negatives inside the radical. So you want to know your signs and
So
index.
it's 2. Oh, I believe yeah.
Okay, so now we don't know the square root of 32 is not a whole number. So the squares that are known to us are this. Square root of 1 is 1. Square root of 4 is 2. Square root of, what's the next one? 9 is 3. Then we have 16. We have 25. Right? What else? 36. 49. What's the next one? 64. 81 and 10. All these numbers have perfect roots. Okay? 1, 4, 16, all the way to 100 here, 100. So this for square root, okay? Square root. All these numbers have perfect square roots, not cubes or 4 here or 6. So 32 is not one of these. So again, what is the square root of 1? That's 1. Square root of 4 is 2. Square root of 9 is 3. 4, 5. So you need to be familiar with these. At least know these ones from the 1 to 10. So the squares of them. 6, 49. What's the square root of 64?
8.
I have
6.
8 and
9 and
Oh,
10.
sorry, it's 8. It's an 8.
okay, so these you need to be familiar with. Okay, you need to know these basics. So if you see one of these, you can immediately get this square root. If it's different than these, for example, you see this 32 here, it's not one of these perfect roots. So we're gonna have to break it down. What do you break it down into? 32. So what numbers multiply to 32? Give me all the options.
16 and 2. Like the perfect one, 16 is gonna be.
Okay, what else?
8 and 4.
I'm sure there's something else.
6 times 6.
Say again?
6 times 6.
Not 6 times 6. 6 times 6 is 36.
Oh,
Is that equal to 32? I believe there's, let's see.
no,
Okay, so,
no, 9.
so which one now do we take to get perfect squares?
16 and 2.
That's right. So both have a perfect root, 4 and 16, but this one is higher. So always go with the higher perfect square. So we're going to turn this into radical 16 times radical 2. This is basically 4 radical 2. So radical 32, or the square root of 32 is basically this. Okay, so that's how you break down radicals when they don't have perfect roots. Works for basically most of the time works for numbers that you can break down into perfect roots. What about this one here? Okay, do we know, what do you think of this? Do we know the square root of 84? It's not one.
No.
It's of the common one. So what do you do here?
We just breaking it.
So
40.
again, look at this expression closely, and always again
Negative.
identify your index, identify what's inside. You want to see whether this is defined or not. So what do you think of that expression? Before you start solving it or simplifying it, always try to figure out whether it's actually defined or not. Is this value defined?
No.
Okay, why not?
First reason it's negative, and then we have index 2, and it's
Exactly.
I guess it's wait, let me see.
So whenever you have a negative inside the radical, check this. This can't be even. If this is negative,
it's even.
Even.
No, it's
so this is even. This is negative.
Yeah.
That's undefined.
Yeah.
So we don't even need to try to do this. So always, again, use these rules. If this is negative, this can be even, and so on. So always check that before you start solving. You may waste time finding something that does not exist. Here, that's it, you stop right here. There's no need to simplify it like this, because it's
if it's 3
undefined.
Instead of 2.
Then
so
you can do that, yes. If this is 3 and you have a negative, then that's fine. Then you try to simplify, try to break this one down if possible into numbers, just like we did with 16.